Hi students, in a previous class we learned about Kirchhoff's rules or Kirchhoff's laws. In this session we will do some numericals based on Kirchhoff's laws. The first question is, using Kirchhoff's rules in the given circuit, determine the current I2 in the arm EF and the voltage drop across the unknown resistor R. In this question, we need to find out this current I2 and the voltage drop across this resistance R. First, you look at the circuit diagram. You can see two loops. This is loop 1 and this is loop 2. Look at the currents given in the circuit. This is 0.5 ampere. Let it be I1. I1, when it reaches this junction E, it joins with this current I2 and leaves from the junction E. Say this current be I3. I3, when it reaches the junction F, I1 goes to this branch and I2 goes to this arm. After choosing the loops, you can assume the current directions in the loop. Let the current direction in loop 1 be counterclockwise and the loop 2 also the current direction be counterclockwise. According to Kirchhoff's current law, I1 plus I2 is equal to I3. Loop 1 is F, B, A, E, F. The path which we travel is from F to B, then B to A to E, and from E to F. This is the path that we are traveling in the loop. We can apply Kirchhoff's voltage law to this loop. Let this resistor be R1 and this resistor R2. This is E1 and this is E2. The first element which we come across when you consider this loop is this resistor R1. You have to find out the voltage drop across that resistor R1. We know voltage drop is IR. Therefore, I1 into R1 will be the voltage drop. But here in Kirchhoff's laws, we must take care of the sign. What will be the sign of this I1 R1? We have assumed the current direction in the loop in the counterclockwise. In this way, I1 is also flowing in the same direction. In the same direction, for a resistor, you must always put negative sign. That is what we learned in our previous class. Then comes this cell E1. For the cell E1, it is from negative to positive. Therefore, for the cell, the value must be positive. That also we learned. For a cell from negative to positive or from low to high, it will be high. Therefore, plus E1. And when it reaches this E2, it is from high to low. From high to low, the value must be low. Therefore, negative minus E2. From this, you can see it is reaching this resistor, then comes back to the starting point F. What will be the voltage drop across this resistor? Plus I2 R2. Why this plus sign? Because the assumed current direction is in this way and the current I2 is in the opposite way. If the current are in the opposite direction, for a resistor you must put positive sign. According to Kirchhoff's voltage law, the algebraic sum of the Voltages in a closed loop must be 0. Now we can substitute the values. I1 is 0.5, R1 is 2, therefore I1 R1 is 0.5 into 2 plus E1 is given as 3, E2 is 4 and I2 we don't know the value, we have to find out that R2 is given in the question as 2. When you substitute these values, you will get minus 1 plus 3 minus 4 plus 2 I2 is equal to 0. What is that? Minus 5 plus 3 which is equal to minus 2. Minus 2 plus 2I2 is equal to 0, or you can say I2, 2I2 is equal to 2 and I2 is equal to 1 ampere. We got the value of current I2 as 1 ampere when you apply the Kirchhoff's voltage law. Now, what is the voltage drop across the unknown resistor R? The voltage drop V is equal to I into R. The current which flows through that R is I3. Therefore, we have to find out I3R. Consider the second loop and apply Kirchhoff's voltage law to that loop. Let the second loop be F, E, let me mark this as C and D, F, E, C, D, F. The path which we travel is from F to E, E to C, C to D and from D to F. The assumed current direction in this loop is counterclockwise. Applying Kirchhoff's voltage law to this second loop, we can write I2 R2. The sign must be both are in the same direction. I2 is in this direction, assumed direction is also in the same way. Therefore, minus I2 R2. This is from negative to positive for the cell. Therefore, plus E2. And when it reaches here, the current direction is in this way. I3 is also in the same way. Therefore, minus I3R is equal to 0. When you substitute the values, you will get minus 1 into 2 because I2 we already got the value as 1. 1 into R2. R2 is given as 2 plus E4. E2 is given as 4 minus I3 R is equal to 0. That is minus 2 plus 4 minus I3 R is equal to 0. That is 2 minus I3 R is equal to 0 or I3 R is equal to 2. 2 volt is the potential drop across this resistor. I3 into R is the potential drop across the resistor R. That is 2 volt. The solution for question number 1 is I2, the current in the arm EF is 1 ampere and the voltage drop across this resistor R is equal to 2 volt. Question number 2. Question is, in the electric network shown in the figure, use Kirchhoff's rules to calculate the power consumed by the resistance R is equal to 4 ohms. The resistance R is equal to 4 ohms is this resistance and we need to find out the power consumed by this resistor. Let us do this numerical. The currents shown in the circuit are I1, I1 plus I2 and I2. When you consider this junction A, I1 and I2 are entering the junction and I1 plus I2 is leaving the junction. Let I1 plus I2 is equal to I3. At this junction D, I1 and I2 are leaving the junction and I3 is entering the junction. Applying Kirchhoff's current law at this junction D, you can write I1 plus I2 is equal to I3. Now we can apply Kirchhoff's voltage law to this loop. Loop D, C, B, A, D. It starts from here, D to C and C to B, B to A and A to D. Applying Kirchhoff's voltage law to this loop, you can write minus I1 into 2. It starts from here. The current here is I1. The resistor is 2 ohms. The first element which you come across is this resistor, which is 2 ohms. What will be the voltage drop across this resistor? IR, that is I1 into R. This negative sign because the current direction assumed is counterclockwise. You must assume the current direction when you choose the loop. When it reaches the cell, it is from negative to positive, from low to high. Low to high, it will be high, therefore positive sign. And the loop, when it reaches this resistor R is equal to 4 ohms, the current is I1 plus I2, which is equal to I3. Therefore I3 into 4 will be the voltage drop across this resistor. And what will be the sign? The assumed current direction is in this way. I1 plus I2 is equal to I3 is also in the same direction. Therefore, minus I3 into 4. We can consider this second loop and apply Kirchhoff's voltage law. The loop is D, A, E, F, D. D to A to E, E to F and F to D. D to A, this, then A to E, E to F and F to D. This is the second loop. The assumed current direction in this loop is counterclockwise. When you apply Kirchhoff's voltage law, you can write I3R minus 6 is equal to 0. The current I3 is in this direction and the assumed current direction is in the opposite way. Therefore, the sign must be positive I3R. When it reaches the cell, it is from positive to negative. Therefore, minus 6. R is equal to 4 ohms. Therefore, I3 into 4 minus 6 is equal to 0. We have two equations in our hand. The first equation is minus 2I1 plus 12 minus 4I3 is equal to 0 when we applied Kirchhoff's voltage law to the loop 1. And the second equation is 4I3 minus 6 is equal to 0 applying Kirchhoff's voltage law to the second loop. Equation 1 can be further reduced to minus I1 plus 6 minus 2I3 is equal to 0. That is equation 1 divided by 2. You can write minus I1 plus 6 minus 2I3 is equal to 0. That is minus I1 minus 2I3 is equal to minus 6. Taking this plus 6 to the other side, it will become minus. Similarly, when you reduce this equation to, you can write 2I3 minus 3 is equal to 0. When you divide that equation 2 by 2, you can write like that. 2I3 minus 6 divided by 2 is 3. Minus 3 is equal to 0. Or 2I3 is equal to 3. Let this equation be 1 dash and this equation be 2 dash. Two equations are there, 1 dash and 2 dash. You need to solve this equation. Add these two equations. Equation 1 dash and 2 dash are now added up. minus 2i3 and plus 2i3 will get cancelled, and you will get minus I1 is equal to minus 6 plus 3, which is equal to minus 3. From that, I1 is equal to minus 3 divided by minus 1, which is equal to 3 amperes. Substitute this value of I1 in this equation 1 dash. I1 is equal to 3 ampere. Therefore, you can write minus 3 minus 2I3 is equal to minus 6. Therefore, minus 2I3 becomes minus 3. Then what is I3 from that expression? I3 is equal to minus 3 by minus 2, which is equal to 1.5 ampere. I1 plus I2 is equal to I3, and that value we got as 1.5 ampere. In the question, they are asking the power consumed by this resistor. P is equal to I squared R. We know this expression. We can substitute this value of current I3 in this power expression and find out P, which is equal to 1.5 squared. R is 4 ohms into 4. This comes to 9. The solution for question number 2 is 9 watts. I1 you will get the value as 3 amperes and I3 as 1.5 ampere. The expression for power is I squared R. While doing numericals, the first step should be you must choose the loop. Then assume the current direction and please take care of the signs while doing the sums. Please practice more numericals from your textbook. See you in the next class.